Hello, Skynet families. Welcome. And once again, we have another episode of the planets. So we are covering about we already covered about the moon, the sun, and also some part of the surrounding solar systems. So today the focus is going to be the entire universe. So again, it's another nice movie, an excellent video. Please enjoy it. I know those Somali speakers who don't understand this episode today, probably I'm working out another episode in Somali language, so probably that one's coming on your way. So let's go ahead and enjoy this one and sit back and watch. Thank you.
Our universe. The universe is often divided as the totality of existence, or everything that exists, everything that has existed, and everything that will exist. In fact, some philosophers and scientists support the inclusion of ideas and abstract concepts, such as mathematics and logic. In the definition of the universe, the word universe may be also refer to concepts such as cosmos, the world, and the nature. The universe is all about space and time and their contents. It comprises all the existence and any fundamental interactions, physical process and physical content, and therefore all forms of energy and matter and the structures they form from subatomic particles to entire galactic filaments. Space and time, according to the prevailing cosmological theory of the Big Bang, emerged together 13.787 billion years ago. And the universe has been expanding ever since. Today, the universe has expanded into the age and size that is physically only in the parts observable as the observable universe, which is approximately 93 billion light years in diameters at the present day, while the spatial size, if any, of the entire universe is known. Further observational improvements led to the realization that the Sun is one of the few 100 billion stars in the Milky Way, which is one of the few 100 billion galaxies in the observable universe. Many of the stars in the galaxy have planets. At the largest scale, galaxies are distributed uniformly and the same in all directions, meaning that the universe has neither an age nor a center. At a smaller scale, galaxies are distributed in clusters and superclusters, which form immense filaments and voids in space, creating a vast form-like structure. Discoveries in the early 20th century have suggested that the universe had a beginning and has been expanding since then. According to the Big Bang theory, energy and matter initially present have become less dense as the universe expanded. After an initial accelerated expansion called the inflationary epoch at around 10 seconds, and the separation of the four known fundamental forces, the universe gradually cooled and continued to expand, allowing the first subatomic particles and simple atoms to form. Giant clouds of hydrogen and helium were gradually drawn to the places where matter was most dense, forming the first galaxies, stars, and everything else we see today. All forms of electromagnetic radiation, including visible lights, travel at the speed of light. For many practical purposes, light and other electromagnetic waves will appear to propagate instantaneously, but for longer distance and very sensitive measurements, their finite speed has noticeable effects. Much starlight viewed on Earth is from the distant past, allowing humans to study the history of the universe by viewing distant objects. When communicating with distant space probes, it can take minutes to hours for signal to travel. In computing, the speed of light fixes the ultimate minimum communication delay. The speed of light can be used in time of flight measurement to measure large distance to extremely high precision. The theory of the relativity usually encompasses two interrelated physics theory by Einstein, special relativity and general relativity, proposed and published in 1905 and 1915 respectively. Special relativity applies to all physical phenomena in the absence of gravity, which relatively explains the law of gravitation and its relations to the forces of nature. It applies to the cosmological and astrophysical realm, including astronomy. Gravitational pull has three other fundamental forces hold the universe together. The strong nuclear force keeps particles in an atom's nuclei from flying apart. The weak nuclear force causes radiation in some nuclei, and the electromagnetic force performs critical tasks such as holding a molecule atoms together. Although the sun's gravitational gives planets billions of miles, gravity is weakest fundamental forces. So, next time when you look up the sky, remember, the sky is the limit.
Welcome once again. I think you guys enjoyed that little pieces of clips that I just put together for our universe. So probably I'm going to make another one for Somali speakers because this is very important information that everybody need to have. So every day we bring different programs here in Skynet. We have news, we have health, we have travel, we have the universe. So just to always get connected and share and always subscribe. That way it motivates us to make more videos like this. So thank you very much for being part of Skynet family.